Every year, billions of trees are harvested around the world. But what actually happens after a tree hits the ground? The answer is far more advanced than most people imagine. Massive machines, laser-guided scanning, fully automated production lines operating with astonishing precision. Today, RaWMachines takes you inside Viewer Lumber to reveal the complete journey of a log, from the forest to perfectly cut lumber. Let's dive in. Decades ago, once trees were felled, teams relied on horses or oxen to drag each log out of the forest. Today, that's no longer the case. Heavy machinery has replaced human and animal labor, making it possible to reach even the most remote and rugged forests with greater speed, efficiency, and safety.
So, hier. Den kann ich doch nicht schade.
At the front of the logging operation is the feller buncher, a powerful machine that grips a tree trunk with hydraulic arms before a cutting blade brings it down close to the base. After each cut, it holds multiple logs at once, gathering them into bundles for the next stage. But moving these massive logs down steep mountain slopes is where the real challenge begins. That's where cable logging comes in. Heavy-duty steel cables are stretched across valleys, lifting logs weighing several tons high into the air. They glide over the forest canopy and deep ravines before reaching the landing site, with little need to carve out additional transport roads on the forest floor. This dramatically improves logging efficiency while minimizing disturbance to the forest soil and natural vegetation. Once the logs have been gathered, specialized logging trucks begin hauling the timber to the mill. Unlike ordinary freight trucks, these vehicles are purpose-built for the forestry industry, featuring heavily reinforced frames, high-capacity suspension systems, and the ability to carry loads weighing more than 80,000 pounds. But the journey is far from over. Mud-soaked forest roads, long, unforgiving climbs, and tight mountain switchbacks demand constant attention from the driver. With tens of tons of timber in tow, every steering input and every touch of the brakes must be carefully calculated to keep the load stable and ensure a safe descent. After hours of navigating rugged forests and major highways, the convoy finally arrives at Biauer Lumber. Here, the forest journey comes to an end, giving way to a new chapter inside the mill, where every log is scanned, sawn, and optimized to maximize its value, transforming raw timber into high-quality wood products. The first stop for these massive logs is the log pond. Why submerge the timber in water? Because the moment a towering tree is felled, it begins a silent race against time. Moisture starts to escape, the wood begins to dry, cracks can develop, and the log gradually loses its ideal shape. For Biauer Lumber, that's value slipping away. The log pond provides the perfect solution. By keeping the logs submerged, the water preserves their moisture, slows the drying process, and keeps the wood fibers stable, allowing saw blades to cut smoothly, accurately, and with minimal waste. Emerging from the soaking pond, each log is transferred onto the stem wave feeding system. But this system does far more than simply move the timber. Its job is to keep every log perfectly stable throughout the process. That stability is critical because even the slightest vibration can compromise the accuracy of every measurement that follows. As the log enters the scanning zone, thousands of laser beams instantly sweep across its entire surface. Diameter, curvature, knots, and even the smallest cracks are captured within seconds. From this vast stream of data, the computer system builds a digital model of each log and calculates the optimal cutting strategy. Every cut is carefully considered to recover the maximum amount of usable timber while minimizing material waste. Once the anthropometric data is locked in, the stem trimmer steps up to make its voice heard. Unlike conventional bucking lines that blindly chop wood to fixed, uniform lengths, every single saw blade at this station takes its marching orders directly from the 3D scanning system. Each blade automatically recalibrates its positioning in real time to strike the exact, mathematically optimized bucking points. In the blink of an eye, a log stretching dozens of meters is seamlessly divided into multiple segments of varying lengths, perfectly tailored for its specific downstream destination. But precision cutting is only half the battle. During a single production shift, thousands of logs must be routed to the exact right line. A single piece taking a wrong turn can ripple down the entire facility, causing massive bottlenecks. That's why, all along the conveyor system, high-speed pneumatic kickers react instantaneously to commands from the central control system, sorting every single log. Premium-grade stock is diverted to the high-end processing area, while the rest is shunted off to alternate lines. Speed and flow sensors monitor the movement in real time, automatically modulating the conveyor speeds to prevent any risk of jams or pileups that could disrupt the flow. Finally, the flying log turner flips the massive log in the blink of an eye, positioning its optimal cutting face for the next saw. The entire maneuver takes less than a second, yet it marks the fine line between producing a perfectly straight, high-quality board and one that falls short of the standard. If the sorting system is the brain that orchestrates the operation, then the sawing line is the blazing heart of the Buer lumber mill. Opening the show is the chipper canter. From the outside, its construction might look deceptively simple, but concealed beneath that heavy steel shell lies a sophisticated piece of engineering where artificial intelligence and raw mechanical muscle merge into one. Watch how it examines the incoming material. The moment a log enters the feed, an intelligent sensor array instantly sweeps the entire surface, measuring its exact diameter and mapping its natural curvature. Based on this live telemetry, the computer directs two symmetrical cutter heads to automatically shift into position, biting precisely into the mathematically optimal depth. What makes this process truly remarkable is that the wood sheared away is never wasted. The shaved off material is instantly collected to produce high-quality wood chips for the paper and particle board industries, or converted into biomass fuel. Thanks to this closed-loop efficiency, virtually no part of the tree goes to waste. With its reference faces now established, the timber moves on to the sideboard profiler and circular quad saw for precision sizing. Here, speed and accuracy must work in perfect harmony. 4 saw blades, each mounted on its own spindle and spinning at thousands of revolutions per minute, cut into all 4 sides of the timber simultaneously. In just seconds, the rough timber is transformed into multiple parallel boards with uniform dimensions and edges that are almost perfectly square. The entire process runs continuously, allowing the production line to handle massive volumes of material while maintaining millimeter-level precision. If the chipper canter lays the foundation, the quad saw defines the standard, shaping every board into its final profile before it moves on to the finishing stages. But nature rarely grows perfectly straight trees. Over decades of growth, wind, snow, and uneven terrain leave every trunk with its own unique curve and grain pattern. If every log were cut along a fixed straight line, a significant amount of high-quality timber would be lost. That's exactly why the TBL3 curve sawing system was developed. Instead of forcing the log to conform to the machine, TBL3 allows the machine to adapt to the natural shape of the wood. Before each cut, an advanced scanning system analyzes the entire log once again, mapping its curvature and the direction of its grain. Using this information, the computer calculates the optimal cutting path and guides the saw blade along a precisely controlled curved trajectory. From the outside, it almost looks as if the blade is gliding effortlessly along the log's natural form, rather than forcing it through a rigid, straight cut. The result is a substantial increase in usable timber, far less waste, and boards that preserve the beauty and continuity of their natural grain. More than just a technological breakthrough, this approach reflects how modern wood processing is learning to use natural resources with greater efficiency, precision, and respect for the material itself. When demand reaches its peak, the mill brings its dual-shaft chipper saw line into operation. The system features 2 parallel saw shafts, each equipped with multiple large-diameter blades. By processing 2 pieces of timber simultaneously in every cycle, it nearly doubles production capacity while maintaining the same level of precision in every cut. Behind the saw line, a high-capacity extraction system runs continuously, removing wood chips and sawdust almost the moment they are produced. This helps prevent blockages, reduces blade wear, and keeps the entire operation running under stable conditions throughout long production shifts. The dual-shaft chipper saw line proves that high-volume production doesn't have to come at the expense of quality. Instead, it demonstrates how modern wood processing can combine speed, productivity, and precision into a single, highly efficient manufacturing system. From the trailblazing chipper canter and the standard-setting quad saw, to the TBL3 that listens to the contours of nature, and the double arbor gang saw that doubles throughput, these 4 stages form the true mechanical heart of the sawmill. Here, the once irregular logs are fully transformed into crisp, precision-cut boards, primed and ready to enter the final refinement phase. The boards have now reached their basic dimensions, but their surfaces still bear the fine marks left behind by the saw blades. To become a finished product, they must pass through the planing stage. As each board enters the planer, cutter heads spinning at extremely high speeds shave away ultra-thin layers of wood from all four sides. Each pass removes only a tiny amount of material, but just enough to create a surface that is smooth, flat, and perfectly uniform. Beyond improving appearance, the planer also brings every board to its exact final dimensions, with tolerances of around 1/10 of a millimeter. That level of precision is essential, ensuring the timber can be fitted accurately in construction projects and downstream manufacturing processes. But achieving the right dimensions is only part of the journey. Before moving on, every board must be carefully evaluated for quality. In the past, this task relied almost entirely on the trained eyes and experience of skilled inspectors. Today, much of that responsibility has been taken over by the autograder system. Using advanced scanning and automated analysis, the system can identify color variations, defects, and numerous other characteristics of each board in a matter of seconds. Meanwhile, engineers continuously monitor the process, verify the data, and perform random inspections to ensure every grading decision remains accurate and reliable. By combining the speed of automation with the expertise of human inspectors, the mill can grade thousands of boards every hour. From that moment on, every board is assigned the right quality grade, the right application, and its rightful place within the supply chain. After grading, the boards move on to the sticker stacker. Here, the system automatically arranges the timber into neat bundles, placing thin spacer strips, known as stickers, between each layer. These small gaps allow air to circulate evenly around every board throughout the drying process. Though simple in appearance, these spacers play a critical role. They ensure moisture escapes uniformly, helping prevent warping, twisting, and cracking as the timber gradually dries. Yet even after being sawn and graded, the timber is still far from ready for the market. Each board retains a significant amount of natural moisture, and if used too soon, it can shrink, warp, or crack over time. That's why the next destination is the industrial kiln, where every board undergoes its final test before becoming a finished product. Specialized carriers transport the stacked bundles into massive drying chambers. Over the course of days, or even weeks, powerful circulation fans drive heated air through the narrow spaces between every layer of timber. Gradually, moisture is drawn out until the wood reaches a moisture content of just 6 to 8%, the industry standard for dimensional stability and long-term performance. Many mill workers describe this as the timber's forging stage. Just as steel must endure intense heat to gain its strength, every board must withstand time, carefully controlled temperatures, and precisely managed drying before it is ready to become part of structures built to last for decades. The journey reaches its final destination at the packaging area. Here, each bundle of timber is securely strapped with steel bands and proudly labeled with its species and quality grade. Every bundle leaving the Buer lumber yard is more than just another shipment. It represents the culmination of 90 years of craftsmanship, a perfect meeting point between nature and technology. From the steep forest slopes where each tree began its life to the trucks that carry the finished timber across the country, the transformation is complete. And with that, the bundles roll out of Buer lumber, ready to begin the next chapter of their journey. If building with brick and stone is a slow, meticulous process, then constructing the log home in Horní Kožlí is a showcase of precision engineering and raw mechanical power. In just 3 days, what began as a quiet concrete foundation transformed into a towering timber fortress, combining the warmth of nature with the craftsmanship of master log builders. Morning breaks over Horní Kožlí beneath a blanket of mist. Heavy-duty trucks loaded with massive round pine logs roll onto the site. A truck-mounted crane extends its powerful boom, carefully lowering the first foundation logs into place. Unlike conventional brick houses, the foundation logs must be milled flat on the underside and drilled with precision, so they align perfectly with the anchor bolts embedded in the concrete slab. Using laser levels, the crew carefully checks every corner, ensuring the entire structure begins on a perfectly level plane. By midday, the pace intensifies. The exterior walls quickly rise past the 5th and 6th log courses. Window and door openings take shape as shorter logs frame clean, square openings. As the sun climbs higher, the walls have already reached nearly 2 meters in height. Attention now shifts to the interior partitions. Shorter logs interlock with the exterior walls through traditional notched joinery, gradually defining each room of the home. This stage focuses on installing the structural support posts and central load-bearing beams. Each vertical timber post is fitted with an adjustable screw jack at its base. This component is essential in traditional shrub log construction, allowing homeowners to fine-tune the post height as the horizontal log walls naturally settle and shrink during the first 2 to 3 years. Massive floor beams for the loft are hoisted into position. Using heavy-duty drills, the builders drive hardwood dowels through multiple log courses, locking the wall sections together and preventing the timbers from twisting as they dry over time. By the end of the second day, the ground floor shell is complete, ready for the home's complex roof structure. Day 3 becomes the crew's ultimate test. Just as the first roof rafters are lifted into place, torrential rain suddenly sweeps across Horny Causley. Raindrops blur the camera lens, giving the footage a dreamlike quality. Yet that very haze makes the workers' determination stand out even more as they continue without hesitation. Rather than being enclosed immediately, the roof is assembled as a fully exposed skeletal timber frame. One slender yet remarkably strong rafter after another is carefully interlocked, creating an intricate lattice of round logs. The project concludes with an impressive structure standing tall, soaked by rain, yet solid and unwavering. It is a powerful testament to the craftsmanship of RaWMachines. A true log home is built to stand strong and be completed even under nature's harshest conditions. From rugged logging machines conquering harsh terrains to production lines packed with thousands of sensors and lasers, every single step is engineered to answer one central question. How do we maximize the value of what nature took decades to create? At Buer Lumber, we witnessed how raw logs are 3D scanned, computer calculated, and milled by systems with near-perfect precision before being planned, graded, dried, and packaged for shipment. Virtually no part of the log goes to waste. Yet, the greatest value doesn't lie in the machinery or the output itself, but in how technology is increasingly adapting to nature. From curve sawing systems that follow the natural contour of the log, to algorithms that optimize cuts to minimize waste, it all reflects a new mindset. Harvesting more efficiently by respecting what nature has built. Leaving the mill is not the end of the lumber's journey. In Horny Kosley, these boards become walls, posts, and rafters, ultimately forming a complete home. In just a matter of days, thousands of components are assembled with high precision, creating structures that will stand with humans for decades. This proves that the value of wood lies not just in the material itself, but in how we craft and preserve it. Looking back at the entire journey, it's hard not to be amazed. A tree takes decades or even centuries to grow in the wilderness. But to transform it into a finished product, modern industry mobilizes an entire ecosystem of machinery, artificial intelligence, precision engineering, and generations of accumulated expertise. This is no longer just manufacturing. It is the bridge between natural resources and human ingenuity. Perhaps the most memorable takeaway from this journey isn't the sheer size of the machines, the speed of the assembly lines, or the scale of the mills. It is how every single step aligns toward one goal: extracting the most value from every log, minimizing waste, and turning a finite resource into structures that will serve people for generations. Thank you for listening to the end of our story. If you enjoy videos like this, please like, share, and subscribe so you don't miss our next stories. This is RaWMachines signing off. See you next time.